Hello everyone, it is August 18th, I'm back again, yeah, let's jump right in. The first thing that I would like to do is revisit yesterday's attempt at making a variable or variably sized array in C, which clearly I messed up on doing. If needed, I'd like to consult ChatGPT or Google Bard just to kind of interrogate the code. I find that actually ChatGPT in particular, I try and use it at work, and it's not 100% great at kind of solving like the novel stuff that comes up. Like I have quite a specific business need that I need to solve, and obviously there you can't divulge too much detail, or if your problem is quite specific to a particular domain. So I ask ChatGPT a lot of questions about Azure, obviously not on this account that I'm using here, but on different accounts, and it's not 100% great, but I think where it absolutely shines is explaining concepts in different programming languages, and also explaining pieces of code that you might give it. That's really where it shines. And then if that fails, we can try Google Bard instead. So, and then after that, I'd like to actually make a start on some of these problems. It's called the CSES. I don't actually know what it stands for. Code Submission Evaluation System. It's a Finnish website, I guess. There are a lot of problems. A lot. I assume they get more and more difficult as time goes on. I'm guessing that these are number of unique people who've submitted versus people who've actually got the question correct. So this is quite the undertaking, but you know, it starts out simply and then just kind of takes a bit of a tumble towards the end. I have heard that some of these also involve quite specific maths knowledge, which I probably don't have. I've always been just very okay at maths, and that's it. And also, years of not studying maths means that my maths knowledge is probably not where it should be to solve some of these problems, but we'll give it a go. Anyway, the first thing that I'd actually like to show you is the I did make reference to a gist yesterday, but there was actually a YouTube video. So give me 1 second. I'm going to pause and see if I can find it. Okay, so this is what I was looking at. So it turns out that it is seemingly possible using just the primitives. What's interesting is that in C, the implementation is to use the new keyword, whereas the C equivalent is obviously using something like malloc.
They have shown in index. To do, we just have to increment s, that is the s will proceed.
So I'm trying to ignore these kind of loops here, but I think it might actually be an exercise in, maybe I was close to the money yesterday, maybe. If I open this to the side and kind of try and see what I was doing and then compare that to perhaps another way of being able to write this. What's interesting is that I was maybe right in my guess, although I suppose maybe not. So if I was to take a copy of this, I hope that actually copied properly. Yes, it did. So I've got some wrapping here. Let me disable the minimap. Oh, hang on. This is my notes file. So let me just see. Why is yanking not working? I really do need to figure out these Vim bindings. Okay, so if I was to try and make a So if I was to try and do this way, it might be worth adapting some of this code. So what it turns out I really don't need is this line or having some kind of like static size declaration here. So I'll leave that as just outer n. I mean, we could call it r, like ARR. And before we mem copy, if we take a look at the outer loop, we can see that in the code example, he is reading the size from cin, which we've done, and then uses the new keyword at outer whatever s is, which is 0, or I think in this case it's at I. This doesn't work either because I've got a typo there. Did I not fix that yesterday? Okay. Whatever. So what we can do perhaps is say that outer I is equal to malloc and then the size of an unsigned multiplied by however big we need this to be. So there is a problem here. A value of type void cannot be assigned to an entity of type unsigned int. So I'm guessing oh yeah, so malloc returns void. Okay. Let's have a look at CPP reference then. Okay, it actually returns your pointer, so okay, now it has an issue with malloc initialization with that expected for aggregate object. So I wonder if viewing the problem. Let's see what the quick fix does. Or let's see how every AI model fares. So what's actually the issue here? The IntelliSense in my IDE. The IntelliSense in my IDE is telling me that initialization with that is expected for aggregate object. Here is my code, or let's say, can you tell me why this is happening? and how to solve the issue. Here is my code snippet. I'm not sure if you can actually... I don't think I'm using inner size here. Let's see how it fares. Also, it has to be initialized with an initializer list. You are trying to initialize it with a single expression. This is not allowed for aggregate objects. So, I mean, really, question number one should have been what actually makes an aggregate object, because I'm not 100% sure, although it does say the following types are aggregate objects in C++. So primitive types, which is what we're using, arrays of primitive types. Outer I is an array of pointers to unsigned integers. Since pointers to primitive types are aggregate objects, the array is also an aggregate object. But is that actually what I want? Because I feel like that's... Oh, yeah, of course. So my outer I is actually, you know, I need it to have... Or maybe not. So it's not... Let me see. Whoops. So I wonder if it's clever enough to do that. So that's what I thought it would be, is that actually you need to... You're just... I guess you're saying that in this initializer list, you want this amount of space assigned. Oh, so you have to cast it outside? I didn't know that. So you're saying I want an unsigned pointer. Can you do that? Okay. Alright, I guess that's something for the notes then. So let's say malloc by default returns a void asterisk, a void pointer, or a pointer to an unspecified type. Therefore, to use it for, it must be cast to a pointer of the type you want it to represent, e.g. for an unsigned integer, it should look like this. So wait a minute, where do we actually have malloc? I would guess it's here. Let me actually figure out where it's specified. Oh, it's in std lib. Or is it in... We look at cmalloc. What do you actually need for that? So there's stdio, but it does say stdlib.h. Where is it finding it here? No declaration? Okay, it is in stdlib. So, guess I need to add stdlib there. So let's say something like that, I think, would work. So then if we go back to what we were having problems with before, I think we can then just access elements using this syntax. So rather than have these two problematic lines here, which obviously produces a segfault, we can do similar to what the person here has done. I guess outer I E is C. So I'm not getting any compiler errors. Not compiler errors, IntelliSense errors. So and then if I go to yesterday's file, oh, okay. So if I was to go back to HackerRank, do we think this would work? Also, does it need to be a new line? Yeah, I guess so. Okay, so if we went to C++, how was I doing it? Variable sized arrays. Let me view solved as well. I don't think it was here. No. Let me look at solved only. Variable sized arrays. So let's see if we get like question 1 right, and then let's see if this actually expands out to all of the other test cases, which it does. Okay, fantastic. Okay. So something I probably should mention as well is that I was actually trying to understand the difference between something like malloc and what am I saying? The difference between something like malloc and the new keyword in C++, which someone said in that GitHub discussion thread. I think that might have been in yesterday's video. And I'm going to assume that this is correct, but on my other ChatGPT account, I asked it, so is the key difference basically that if you use malloc, it doesn't, or, you know, rather, is the key difference between the new keyword in C++, is it that, you know, in C++, using new will not only, you know, assign the memory space required by the object, or like allocate that memory, but also call the constructor of the object, versus in C where it just, you know, literally allocates the memory size. And allegedly that is a correct understanding, so that's good. Okay, so that's actually really cool. Okay, I guess once something I should also put in the notes then is that you don't have to do like memory addressing or anything like that. You can still access things kind of element wise using using indices. So let me put this on two sides. So we declared our outer just as a pointer, and then of size n. Then for each element in the outer array, to allocate the space required by the elements of the subarray. To do so, we accessed, I'm actually going to wrap those, the elements of outer using we were able to access the subarray same way and assign values this way too. So let me just copy like that snippet up here. And then I think the only thing I really need there is stdlib and iostream. Yeah, okay, I think that's all we need. Nice. So let's try some of these CSES problems. So I had a click at the first two, and they don't seem that complicated, as indicated by the fact that not that many people proportionally actually got it wrong. So give me 1 second, just going to pause, and I'll be right back. Okay, I think I'm going to have to make an account here, so give me 1 second, I will go ahead and do that. Okay, the account has been made. Let's try and do weird algorithm. So consider an algorithm that takes input as a positive integer n. If n is even, the algorithm divides it by 2, and if it's odd, it multiplies it by 3 and adds 1 until n is 1. Okay, this, yeah, it does seem pretty straightforward. So let's do... Actually, let's say weird algorithm file there, and it needs to be in this folder. Yes, it does. Okay, so I actually think like this is pretty straightforward thing to implement. So I'm just going to go ahead and type away. So the first thing we obviously want is IOStream, and then our int main. We want to basically read. Okay, so it's going to be unsigned because it's going to be greater than 1. So we want to read something from input, and that's going to be our number. Let me use namespace std here just to make it simpler. And then we will say while n is not equal to 1, we need to do this sort of logic. So if n... okay, I guess modulus division is that. So if it's even, so if we don't get a remainder when we divide by 2, or when we do the modulus operation, if we don't get a remainder, then obviously it's even. So we then want to we want to divide it by 2. Otherwise, I can put that in that line. And I'm missing a semicolon there. We then want to say that n is n times 3 plus 1. And every time we do this operation, we then want to actually print n plus a space, I'm guessing. And then we can see what that gives us. So if we said 3, we should have 10, 5, 16, 8, 4, 2, 1. Yeah. Okay. It might actually yell at me about the formatting there, that I have a trailing space. So if we make this a little bit fancier, we can basically just say n is not 1, then print a space, and then we can get rid of the spaces there. Woohoo! Okay, I think that should be fine, so let's go ahead and submit that. So let's find our code. Learning. This is our weird algorithm. Submit. Oh, wait, wrong answer? What? Oh, it needs to... Oh, it always needs to initially output n. Okay. Wait, but then my demo one was right? I go back. Oh, no. Okay. Right, fine. Okay. Fussy. Probably I could optimize the C-outs there, but who cares? There we are. Okay, I have some wrong answers. In fact, a large chunk of this is missing. What did I do the first time? Right answer. How weird. What? I don't understand how that could be... How that could be wrong. Thought it was foolproof. So if you start with a massive number... When does it start to deviate? It starts to deviate at around here. It starts to deviate at around this number. So the correct one goes up to that. The wrong one goes to that. Maybe, oh, maybe it needs to be a big old integer. So instead of making that an unsigned, if I just made that like frickin' huge. Ah, there we go. What was the problematic number? That one. Whoops. Although this is all on one line, so I don't know if grep's actually gonna work. Or maybe my command's messed up. Or I could just do it the other way around. Like... so 704511. It's not in there. Did I use the right... Oh, maybe it would help if I used the right file. This one? Or is it this one? Okay, it is this one. So if I tried it again with... what is the number 270271. Okay, so it did give us that result at least. Right, okay. That's obviously something you need to worry about, like the size of your containers. So let's just try that one again. Yay! Okay. Small pause, then on to the next one. Okay, hey. So let's move on to the next one, which is missing number. So I'm given all numbers between 1 to blank except 1. My task is to find the missing number. So I think clearly what we can do here is just have two maps and then find the difference between each one, which should be a single element. So I've never actually used a hash map in CPP before. Well, maybe it's not a hash map, but like actually just a set. Sorry, talking absolute rubbish. Just a set, and you take the two. You take the difference of the two sets, and then that just gives you your number. So you're not searching. You're not doing that kind of two-tiered search. Or you're not doing like, okay, look in the smaller array at element 1, check every element in element 0 to see if it's there. We can just use a set. So let's see what we can do. So you can have a set, I suppose, of a certain type, and then insert. Now, is it actually trivial to get the difference of two sets in C++? Yes, you can. So we can take set difference, which is from, as long as it's not third party, which I guess it's not. You set difference found in algorithm. Okay. Okay, that definitely doesn't seem complicated. Let's do set difference. So I think these are the two key things that we're going to need. So let's start by, we obviously want to include IO stream, we want to include set, and we're going to want to include algorithm. And then what is our input format? So two times 10 to the 5 shouldn't exceed 512 megabytes. No. Nowhere near. Okay. So the number we read is kind of the size of the set that we want to make. So I'm just going to call it S. And obviously let me use namespace std here. So let's see in the value of S, and then we can say for in I equals 0, I is greater is less than S. We can have a set that we insert to. Hopefully this isn't too slow. I don't think it should be, but let's do that. So So to construct a set, I'm just going to call this set unsigned base. Base insert I. And I actually think we do want to have a less than or equal to. Actually, isn't there? There is an iterator that we can have. Oh, or we can just say size. So let me try. Need to move that file in here. Ah, okay. That does, of course, need to be unsigned. If I was to do 5, okay, we have 6, so actually I don't need that. Although, I say that, I might need to if in our problem it actually starts at 2. Have I constructed that right? Yes. I hope. If our size is 5, yeah, that should be fine. I hope. And then we want to say set comp, which is going to be our compare. So for unsigned I equals 0. I let's insert let's get our number, wrong way round, and we'll insert that number here. Let me just try that one more time. Yep, okay. Think that's good. So if we get rid of those, so we now have our base set and we have our set that we want to compare to. So let's see. Set difference. So if we look at how we're supposed to use this, input iterator first one, input iterator last one. Oh, let me not do std, cout. Hmm. Is it? It's an ordered container. Ah, okay, gives those elements that appear in one of the sets but not both. And the symmetric difference. Ah, okay, okay. So I don't need to necessarily extract that iterator to a variable. I can just say okay, I do want set difference, which are not found in the sorted range base. Okay, so I actually want comp dot begin, comp end, then base begin, base end. Then what is this inserter? This is where you're actually putting the output. Set symmetric difference. I did see a really good example of it somewhere. I think it might have. Oh yeah, it was here. Okay, so that's a vector. Let's use that example then. So to use this algorithm, I have to put it into yeah, and then we can do this. So there's 4 unsigned n in V. We just want to cout n, and that should be the difference. I hope so. Let's see if this works. So our number 1 is 5, and then 2, 3, 1, 5. Our output was 1. That is very wrong. Because obviously what it should have been is 4. Have I actually got my... Wait, but then it would have said nothing, right? Guess you could do it the sorted way, maybe. Like using 2 sorted vectors, but who knows. Set difference of 2 sorted ranges. I mean, is this... Can I actually use this on a set itself? Okay, well it is sorted, so it should work. So what have I done wrong here? Copies the elements from the sorted range which are not found in the sorted range first 2. Yep, so I've got my parameters the right way around. So what did I do wrong? So let's use this syntax here. And sorry, that's not V. That's what I get for reading the documentation. So I'm making an iterator, which I'm setting to obviously be at the beginning of our base set, then basically going through that iterator and printing each value each time. So let's go ahead and copy those and use this down here as well. So this is actually going to be our comp elements, comp. Okay, so let's use the example from before, which is 5, 2, 3, 1, 5. Segmentation fault. Wonderful. What have I done wrong? It's got to be an error that I've made there. Probably because it's not that. Okay, so 5, 2, 3, 1, 5. Those are my base elements. And comp elements 1, 2, 3, 5, and 1. Where is it getting that extra 1 from? Where is the 1 coming from in the input? What? How weird is that? Right, so 5, 2, 3, 1, 5. Oh, wait, it didn't even let me do that time. Let me just put this into like a text file. 1, 2, 3, 1. Why is it not 5? Also, that I realized is actually this is not quite right because I've got one extra element in there. Hmm. Num insert num. Those are my base elements. Take the set difference. Unsigned I equals 0. But then the problem is if I only go to s plus 1, my thing is, my array is going to be too small. Wait. No, never mind. Why is it just... I think the only thing that's going on here is that it's just not reading the sets right. So as soon as I can, overcome this problem, then we can figure it out. So let me clear this and actually give that another try. 2, 3, 4, 5, 6 is still wrong, but it's probably because I haven't done that. My base elements are not... Oh, you're given between 1 and n. I really need to read the question. It's my biggest weakness. Okay, 1, 2, 3, 4, 5, and then 1, 2, 3, 5. So actually, this should now work. And I need to save this. Back down here. Okay, now I have nothing. Which is strange. Because it looked like it read that fine. 1, 2, 3, 5 is in my second set. So where is my output? Because I've got two sets, I'm taking the difference of them. It should have found that missing number. And it was doing it before, which is the really weird part. It's 0. Boy, what makes it 0? How can it be 0? Oh, I have so much to learn. I also think I'm really overcomplicating this problem. I'm sure I am, but I'm way too invested now. I don't understand the issue. The output vector size is that. There's back inserter or std inserter. I don't think it's that's the issue though. Unless it's something like this, which I have seen before. No, it's still 0. Oh, do they need to be... Oh, please don't say they need to be the same size. But that, yeah, that couldn't work, so... A range of elements to examine. A range of elements to search for. The beginning of the output range. And then I don't need policy or comp. Man, I don't know why this doesn't work. Where is my error? Because I know that I'm reading this correctly now. And I can't be misusing set difference. Although, maybe it's actually that I do need to have these swapped around, because when it was giving me the right answer when I had it the wrong, well, not the wrong way round, but when comp was just reading random stuff. Okay, okay, that is correct. So that should be fine. So did I read this the wrong way round? Copy elements. Oh yeah, okay, I read it the wrong way round. Oh, okay. It's always annoying when that happens, but there you go. Let's see then if this code is acceptable. Yes. Nice. And it wasn't too slow or anything like that. It was fine. Cool. Okay. I'm going to leave it there. It's just been over an hour, but already learned quite a bit. Gonna write up maybe a couple of notes here on the iterator, because I think that was brand new. A lot of the set operations I was already aware of, but also set difference. I should make the note that you want your complete set to be first, and then your comparison set to be at the end. I might copy this snippet in terms of sort of how you can use set difference and then print the output. But yeah, that was that. All right. Thank you very much. See you next time.